Welcome to Integrated Science Intervention Program for Senior High Schools. Today's topic is mole concepts, and the lesson title is Moles in Solution. I am Esiama Kufuor, your facilitator. In our previous lesson, we looked at the relationship that exists between mass and amount of substance or number of moles of a given substance. You were given assignments. Please present the question 2 of the assignment that you were given. You have 10 seconds to present your work. Welcome back. Let us see how you solve it. The question was, calculate the mass of 0.25 moles of magnesium atoms, given that the relative atomic mass of magnesium is 24. As usual, we are going to use the problem-solving strategy to solve the question. Now, the analysis of the question gave us N is equal to 0.25 moles, relative atomic mass of magnesium is 24, and the unknown is lowercase m. But by definition, lowercase n is equal to lowercase m divided by AR, which is the relative atomic mass. So if we want to make lowercase m the subject of the formula, then we will have to multiply both sides of the equation by the denominator of the equation. And when we do that, the expression is what is seen on your screen. Now, you will see that AR is appearing as numerator and denominator in the expression. So they will cancel out, leaving the expression to be lowercase m is equal to lowercase n multiplied by AR. Substituting the values into the equation, we will get m is equal to 0.25 times 10 raised to the power 24. And this will give us an answer of m being equal to 6 grams. Then, as usual, you evaluate your answer to see whether you have stated the correct unit of measurement. In this lesson, we shall look at moles in solution. In this lesson, we are learning to define the concentration of a solution. We will calculate the amount of substance of a solute given the volume of the solution and concentration. We will calculate the concentration of a solution given its volume and mass of solute. The lesson has been structured into two main sections. In section 1, we will be looking at concentration of a solution. In section 2, we will be performing calculations involving concentration of solutions. Let's look at the key words of today's lesson. They are solution, concentration, molarity, amount of substance concentration, and mass concentration. Let's begin with concentration of a solution. Now, let me ask, what is a solution? A solution is a homogeneous mixture of two substances. When we say homogeneous, what do we mean by that? If I put two substances together, a solid and a liquid, and I blend them so that the solid dissolves in the liquid and the particles of the solid or the liquid cannot be seen by the naked eye. And when the solution is left to stand, or the mixture is left to stand on its own, the particles will not settle on standing. Then we say that we have formed a uniform mixture, and this uniform mixture is called a solution. A solution has two important parts called solute and solvent. What is a solute? A solute is a substance that is dissolved to form a solution. So for example, if I have a salt and I put salt in water, I blend it such that the particles dissolve completely, and I cannot identify or see the salt particles in the water. Then I have formed salt solution. When such a solution is left to stand, the particles of salt will not settle on standing. Therefore, salt is an example of what? A solute. Similarly, sugar is also an example of what? A solute. And therefore, if I dissolve sugar in water, then I'll form what we call sugar solution. So a solute is the component of a solution which is present in small quantity. Now let's look at solvent. It is the dissolving medium of a solution. For example, water. It is the component of the solution which is present in large quantity. Now let's turn our attention to the amount of solute in a given solvent of a solution. Now, is it possible to determine the amount of solute in a given volume of solution? The answer is yes. The quantity of a solute present in a unit volume of solution is termed as concentration. It is the units of solute and solution, or the solvent, can be expressed in 4 different ways. So there are 4 different types of concentration, namely amount of substance concentration, mass concentration, molar concentration, and mole fraction. Let us consider amount of substance concentration. It's defined as the amount of solute dissolved in 1 cubic decimeter of a solution. Note, it is solution but not solvent. It is denoted by C. It is also known as molarity and denoted by uppercase M. Its unit is mole per cubic decimeter. And mathematically, amount of substance concentration is defined as C is equal to N divided by V, where N is a fundamental quantity called amount of substance or number of moles. Its unit is mole and its symbol is MOL. And V is the volume of the solution, not the solvent, but the solution. And it is measured in dm cube, cubic decimeter. Now, Let us use this formula to solve the following question. So take your pen and paper and answer this question. Calculate the amount of substance contained in 250 cm cube of 0.5 moles per dm cube potassium hydroxide solution. You have 20 seconds to present your work. You can start work. Welcome back. Let us see how you were able to solve the question. As usual, we have to analyze the question. And if we analyze the question, we have two knowns and two unknowns. The two knowns are concentration in moles per dm cube, volume of the solution in cm cube. Then the unknowns are volume of the solution in dm cube and amount of substance or number of moles. Now we need to plan how you will solve the question. The volume was given to you in cm cube, but by definition the volume is supposed to be in dm cube. So we have to convert the volume from cm cube to dm cube by dividing by 1000. Then we use the formula N is equal to CV to solve the amount of substance. So in the question, we have V being equal to 250 cm cube. If we divide by 1000, we will get 0.25 dm cube. Our C is 0.5 mole per dm cube. And the quantity being sought for is N. By definition, C is equal to N divided by V. How do we make N the subject of this formula? You will agree with me that we have to multiply both sides of the equation by the denominator, and that is V. And when we multiply both sides of the equation by V, we'll arrive at N is equal to C times V. Let us substitute the values into the equation, and that will yield N is equal to 0.5 moles per dm cube multiplied by 0.25 dm cube. You will see that we have per dm cube and dm cube in the expression, so they will cancel out, and our answer will be N is equal to 0.125 moles. So you go ahead and evaluate your answer as usual to check whether you have stated the correct unit of measurement. Now let's turn our attention to mass concentration. What do we mean by mass concentration? It is defined as the mass of a solute dissolved in 1 cubic decimeter of a solution. It is denoted by rho. The symbol of rho is what you see on your screen. Mathematically, it's defined as mass concentration is equal to mass divided by volume in dm cube. Question 2, it reads, calculate the mass concentration of a solution prepared by dissolving 20 grams of sodium hydroxide, NaOH, in 500 cm cube volumetric flask and topping it up to the mark with distilled water. You have 20 seconds to present your work. Welcome back. Let us see how you should have solved the question. As usual, if you analyze the question, then you are going to get two unknowns and two knowns. The two known quantities are the volume of the solution in cm cube and the mass of the solute in grams. Then the unknowns are the volume of the solution in dm cube and the mass concentration. Now, you will have to convert the volume in cm cube to dm cube because the definition of a concentration is the mass dissolved in 1 decimeter cube, and 1 decimeter cube is 1,000 centimeters cube. So you have to divide it by 1,000. Then we use the formula rho is equal to m divided by v to calculate the mass concentration. So you were given v to be 500 cm cube. If you divide it by 1,000, you will get 0.50 dm cube. The mass m is 20 grams, and the quantity being sought for is rho. By definition, rho is mass divided by volume in dm cube. Substituting the values into the equation will yield mass concentration is equal to 20 grams divided by 0.50 dm cube. And it will give us our final answer to be mass concentration is equal to 40 grams per dm cube. Then, as usual, you evaluate your work to see whether the unit that you gave the answer is correct. Remember, omission of unit attracts penalty, and wrong unit also attracts penalty. All too soon, we've come to the end of the lesson. What have we learned today? We learned that concentration is the quantity of a solute present in a unit volume of solution. We also learned that there are 4 different types of concentration. Then we learned that molarity is defined as the amount of solute dissolved in 1 cubic decimeter of a solution, and mass concentration is defined as the mass of the solute dissolved in 1 cubic decimeter of a solution. Now I'll leave you with these exercises to try your hands. Question 1. Define the following terms. A. Molarity. B. Mass concentration. Question 2. Calculate the amount of substance or number of moles contained in 100 cm cube of 0.20 moles per dm cube ammonia solution. Now, let us look at our challenged question for today's lesson. And that is question 3. It reads, calculate the mass of solute required to prepare 100 cm cube of 0.75 mole per dm cube sodium chloride solution, given that the relative atomic mass of sodium is 23 and the relative atomic mass of chlorine is 35.5. In our next lesson, we will look at how we prepare a standard solution. Thank you for having me. Try your hands on all the solve questions and use the concept to solve past questions. Check more definitions and commit them to memory till we meet in our next lesson.